Today we're going to be talking about similar polygons. So if you remember, a polygon is a shape. No curves, no crossovers is what I talked about in class. Nice closed figure. A similar polygon would be like if I had a really small triangle and then I just blew it up to a really big triangle, but yet I keep the same proportion. Now think about that word, keeping the same proportion, because we're going to talk about that today. So two polygons are similar if they're corresponding angles are congruent, okay? So two polygons are similar if their corresponding angles are congruent. You always check for that. And then you also want to make sure that their corresponding side lengths are proportional. Okay, so those are the two main things we're going to talk about today. We're going to have two shapes. We're going to ask ourselves, hey, is this similar? And the only way we can answer that question is if we check to make sure all the angles, the corresponding angles, are congruent and that all the corresponding side lengths are proportional. So that's what we're going to work on the next problem. So is triangle cat similar to triangle dog? That's how we say that. That means similar right there, in case you're wondering what that mark means. Okay, they want to know if those two triangles are similar, and let's talk about how we're going to prove that. Well, first things first, I kind of messed up and I forgot to mark these triangles for you guys. So if we can go through here really quickly and just mark some angles here that I forgot to mark in for you, that would be wonderful, and I apologize for forgetting to mark those in for you. So the first thing they want you to check, list all the pairs of corresponding congruent angles. Now you could look at the picture and say, ooh, C and D, they have the same arc mark, so those two must be equal. But using the picture is fine. I tend to use this right here. So is C and D, are they equal? They are. And then look at this. A is in the middle, O is in the middle. Are A and O equal? Are they equivalent? They are. They both have two arc marks. And then T and G, are they? And then you look there, and they are. So you would say C is congruent to D, angle A is congruent to O, and angle T is congruent to G. Now you're probably asking yourself, why do we have to list this? Like, what is the point? Well, in order to prove that two polygons are similar, you have to say their corresponding angles are congruent. You have to. If you leave that part out, then you haven't proved to me that they're similar. So make sure you do include that. Next, write the proportional ratios and check they're congruent. All right, so I tend to use this, okay? So I would say CA goes with what? Well, CA are the first two letters, and the other one, DO. And I like to list all of them out first. So we have CA and DO. The next one I'll do AT. What goes with AT? Last two letters, OG. And then the last one, we have to put C with the T, and that'll go with D to the G. Okay, so I'm just using this right here. If you want to use the picture, that's fine. I use the similarity statement. So looking over here, CA is 6, DO is 9. So 6 divided by 9. Now I want you to reduce this. There's a factor of 3 in both of those, so we'll have 2/3, okay? So I'm going to kind of circle that there so we know. Then we have AT over OG. AT is 10, OG is 15. 10 over 15. And when I reduce this one, I get 2/3 also. All right, now let's go to the last one. We have CT. So 12 is CT, and then DG, which is 18. So 12 over 18. And when I reduce this, because they both have a factor of 6 in them, we have 2/3. Now look what happened. Look what happened. When we reduced each one of these ratios, they were proportional. They all gave us 2/3. This has to happen, guys. If this does not happen, if you don't get the same number for all three, they are not similar. If you don't get the same number for all three, they are not similar. This means that they're proportional, okay? And you need that. That was one of our two things. So also, your book, we also call this little reduced ratio here the scale factor. So remember, I don't know if you remember, we were talking about like 2 to 3. Remember we talked about how you can write it that way? This triangle is 2 to 3, small triangle to large triangle. So that's where this comes from. You don't have to know that. I'm just trying to link it all together for you guys, okay? So congruent, corresponding angles, proportional side lengths. So what I'm going to have you guys do, you're going to do this one on your own. So go ahead and do this one. You can either pause right now and do it. You can finish the video and do it after you're done watching the whole video. Whatever works for you, that just needs to be done when you see me in class the next time, okay? All right, let's go to this next page here. We got Smiley here. Smiley, it says set up the proportional ratios. It looks like they already started it for us. And remember what I said, I like to use this guy right here. So SM went with LE, okay. MI will go with EY. And then last we have SI, and that goes with LY. Like that. And now they said substitute in the values. So they did SM was 8 and LE was 6. Now I have MI, which is 16 in my picture, and EY, which is X in my picture. And then on this last one we have SI, which is 12 in the picture, and we have LY, which is Y in the picture. Now, what is really going on? We have some variables here, right? And that's the whole point. We're using similar polygons in order to solve for X and Y, okay? They're telling you it is similar. They're not asking like, hey, is this triangle similar to that one? They're not asking you that. They're telling you it is. And now we're going to use that knowledge, and we're going to solve for X and Y. All right, there's a lot of fractions going on here, and students sometimes get confused as to what to use, okay? Do you see that there are no variables there? That right there is your unreduced scale factor. Your unreduced, and I'll talk about that in a second, scale factor. And what you're going to do is you're going to set him equal to this, and then you're going to set him equal to that one. So let me write that down. So we're going to have 8 over 6 equals 16 over X, and then we'll also have 8 over 6 equals 12 over Y. And what you're going to do is some cross multiplication, which we've already learned in class. So 8 times X equals 6 times 16. So we have 8X equals, and then 6 times 16, when you work that out in the calculator, get 96. And that's 8 times X. The inverse of multiplying is division. So we would divide and we will have X equals 12. So we've solved that one. Now we have to work on our Y. And we're going to do it the exact same way. We're going to cross multiply. So 8Y equals 6 times 12. 8Y equals, tap, tap, tap away and find out what 6 times 12 is. And once you do that, you get 72. And then it's 8 times Y. The inverse is division, so go ahead and divide, and you have Y equals 9. All done. So you just use similar polygons to solve for X and Y. And then we have to do this last part. What is the scale factor? Well, there's a big old circle or bubble on your page right here. It says scale factor, right? And I told you it was the unreduced scale factor. So let's write that down. It's 8 over 6. Don't you dare leave that as your scale factor, though. 8 and 6. There's a factor of 2 in each of those. So 2 goes into 8 4 times, and 2 goes into 6 3 times. So there is our scale factor, okay? Now remember, if I went too fast, you can always go back and rewatch. What I would probably do, I mean, this is just me and this is how I learn. I actually would watch the whole video and then I would go back and write everything down and watch it a second time. But that's just me. Everybody learns differently. Whatever gets you an A in class makes me happy. This next problem right here, I'm going to have you all do. So make sure you have this problem completely done when you come into class and see me the next time. And I do want to make a little note down here because we're going to talk about it in class, okay? If two polygons are similar, the ratio of the perimeter is equal to the ratio of the sides, okay? We're going to talk about a little bit of that in class. You're going to run into that, and we'll cross that bridge when we come to it, when you see that in class. So go ahead and finish this up, and I can't wait to look at this and give you your A+ for making sure you got all your notes done. See you then.